Right, this is the P4 Jan 2024 question 4 is connected rates of change question with a cone. So we've got a cone shown, and we've got fixed height, so the height is always 5. The radius though is changing, and the slant height is changing as well, obviously. We've got to find an expression for L in terms of R. Well, one mark is just using Pythagoras. 5 squared plus R squared gives you the L squared. So the L is the square root of R squared plus 25. And it says, given that the base radius is increasing at a constant rate of 3 centimeters per minute, we've got to find the rate at which the surface area is changing when the radius of the cone is 1.5. So we've got to find out what the rate of change of the surface area is, which ds over dt. We're given the rate of change of the radius, the dr over dt, and we connect the two of them, sort of chain rule really. The drs on the right kind of cancel, so you just got ds over dt on the right hand side. So the ds over dt is what we're trying to find. We know dr over dt is 3 because it tells us that in the question, increasing at a constant rate of 3 centimeters per minute. We just got to find the ds over dr when the radius is 1.5. Tells us the formula for the surface area of the cone. So we've got the base and the slant area, pi r squared plus pi rl. But we need ds over dr, so the s differentiated in terms of r. So we'd like it all in terms of r really. So I'm going to change it to that, replacing the l with the square root of r squared plus 25, which we got in the first part of the question. I'm going to write like this so I can differentiate it. So the ds over dr then, differentiate in terms of r, so it'd be 2 pi r for the first term, that's the pi r squared differentiated. The other term, the more complicated one, I'll use the product rule, so it's the pi times r. Well, r differentiates just 1, so it's really pi times the square root of r squared plus 25, r squared plus 25 is a half. And then I'm going to do pi r multiplied by that square root differentiated. So the half will go in front. It'll be r squared plus 25 to the power of 1 less, and multiplied by the bracket differentiated, which is just 2r. I'll simplify a little bit. I've got a 2 on the top and 2 on the bottom in that last term. So I'm going to have pi times r on the top. And then I'll have the square root of r squared plus 25 on the bottom. I need to put in 1.5. And when I do that, I get ds over dr is about 27 and a bit. So then I can write that the ds over dt is that 27.178, the ds over dr, and multiplied by the dr over dt, told us in the question that was 3, giving me 81.5. Subscribe and request a solution.